Okay, now let's discuss this practice exam. First problem. Solve two equations. Number one, equation 1, logarithmic function with a base 3 of x plus 1 plus logarithmic function with base 3 x plus 4 is equal to number 2. Okay, so here we're going to apply the property that log am plus log an is equal to log am times n. Okay, for the left side, so it's a log 3x plus 1 x plus 4 is equal to 2. Okay, and then remember that log a x is equal to y. By definition of a logarithmic function, it means x is a to y. X is equal to a to y. So this is a x plus 1 times x plus 4 is equal to 3 squared. You move 3 to the right side, it is still the base. 3 squared is 9. Okay, then you multiply it out and write this quadratic function in the standard form and solve it. Okay, it's x squared plus 5x plus 4 is equal to 9. You move 9 to the left side, you get x squared plus 5x and minus 5 is equal to 0. This one we must apply the quadratic formula, the root formula. Remember, x is equal to 2a, numerator negative b plus or minus square root of b squared minus 4ac. Alright, so a is a 1, so here a is equal to 1, b is equal to 5, and be careful, c is equal to negative 5. Okay, so 2a negative b plus or minus square root of b squared, 25, minus 4ac. Okay, so let's simplify it. So negative 5 plus or minus, it's a minus 20, is plus 20, so it's a square root of 14.5 over 2. Right, 25 plus 20 is 45. 45 is square root of 9 times square root of 5. 9 is square root of 9 is 3. So it's 3 times square root of 5. At this step, we do not finish. Be careful. At this step, we do not finish. So we have two solutions, negative 5 plus square root of 5 over 2. Or x is equal to negative 5 minus 3 square root of 5 over 2. These two are the solutions of the quadratic equation. We never say they are the solution of the original equation, because remember the logarithmic function x plus 1 must be positive. X plus 1 must be positive. X plus 4 must be positive. But if you check this, when x is equal to negative 5 minus 3 square root of 5 over 2, x plus 1 will be negative. It will be negative. Actually, this one is also negative. But so this is not a solution. X cannot be equal to negative 5 minus 3 over 2. So there's only one solution. negative 5 plus square root of plus 3 times square root of 5 over 2. This is a positive number, plus 1 or plus 4. They are still positive. Okay, so these are the first computation. Be careful, the domain of the logarithmic function. The domain of logarithmic function must be positive, be the set of all positive numbers. All right, so that's our first part. And second one, we have the 3 to the power of 1 minus 2x is equal to 4 to x. We'll solve for x. Okay, so you can have multiple choices, but in principle, we are going to take logarithmic function of both sides. By experience, some of you may take a logarithmic function with base 3. There others will take a logarithmic function with base 4. Or even you take a natural logarithmic function. Either works. They are all correct. For example, if we take the logarithmic function with base 3, so I say the following. See here? I just directly apply the logarithmic function for two sides. And this one, left side becomes 1 minus 2x. Logarithmic function is used to compute the power. If you have the same base, then they cancel, you directly get 1 minus 2x. And the right side, log a to x, log a of x to r is equal to r log ax. So you're going to move x forward. Okay, move x forward. And then you continue. You move x to the left side and 1 to the, I think you can move 2x to the right side. So it's 1 is equal to 2x plus x log 3, 4. And you interchange two sides. I want positive sign. That's the only thing I do this additional step. And then factor out x. And then you divide this equation by the coefficient of x. So x is equal to 1 over 2 plus log 3, 4. Okay, so this is the answer. This is a correct answer. If you do not apply log 3, you can apply, for example, if we apply natural log. So I'm going to do the same problem but with a different choice. If I apply the natural log, ln, you see, apply the natural logarithmic function but choose choose e as a base. Then we only apply this property. You move this coefficient forward, 1 minus 2x, log 3, x log 4. You multiply it out, you will get 1 times log 3 is log 3 minus 2x log 3. So 2 log 3 times x is equal to x log 4. I'm going to move this term to the right. So 2 log 3x plus x log 4. And then you factor out x. 2 log 3 plus log 4. And divide the equation by the coefficient of x. You will get x is equal to log 3 over 2 log 3 plus log 4. This is also the right answer. These two answers are actually equal by the change of base formula. All right, so for this problem, you can just choose one of those method and compute it. You don't have to do both or even more, just one. One is enough. All right, so problem 2. This is a word problem. So basically, a child is spinning a rock. So this is a child. He has a rope and then he spins the rock. The trace of a rock is a circle. Okay, so when he spin it, then it has the angle speed, and this rock has a linear speed. Angle speed, linear speed. Assume the linear speed is v, the angle speed is w, then v is w times r. The linear speed is angle speed times radius. What is the radius? Radius is the length of the rope, 2 feet. 2 feet. Okay, so a question, what is the linear speed of the rock when it is released? When it is released, the rock will fly along this tangent direction. That is exactly the linear speed. So v is w in the problem, it is given equal to 3 pi. So it's a 3 pi times 2 feet. So it's a 6 pi. I believe the unit will be feet per second. And that's it. The linear speed of the rock is 6 pi feet per second. Okay. Problem 3. Problem 3, we are talking about a sector of a disk. A sector of a disk. So we know the radius is 2 inches. Theta is 30 degrees. And we're looking for S. What is S? S is the arc. This is arc, the corresponding circle part. Corresponding circle part is the arc. A denotes the area of the sector, of the sector, like the piece of pizza. Okay, so here we need change this 30 degrees into pi over 6. 30 degrees is equal to pi over 6. So we have a question, when do we use degrees, when do we use angles, readings? If you are just interested in the trigonometric functions, then you can use degrees. If you only care the trigonometric functions, you can use the degrees. If you are going to use the angles with other quantities, not just the trigonometric functions, for example, like this, you are going to use this angle speed with the radius directly, then you must use a reading. Okay, so here the same thing. What is the formula of arc length and the radius and the angle, central angle? S is r theta. And what is the A? Well, this is a part A. And part B, we have different. We have r is 3 meters, theta is pi radians. We're looking for A. A is area. Area is 1/2 pi r squared. Or theta. 1/2 theta. 1/2 theta r squared. So you see here, this angle is directly computed, multiplied by r. So this place, you have to use a radian. So let's compute them. S is r theta. R is 2. Theta is pi over 6. So 2 times pi over 6 is pi over 3. This is a length. The unit, inches. Area for the second part is 1/2 theta r squared. Theta is a pi, 1/2 times pi. R is 33 squared is 9, so it's 9 pi over 2. 9 pi over 2 meters squared. Meter squared. Okay, so this is the formula and the value. So be careful about the first part. You cannot directly use 30. 30 is degree, not a radian. Degree cannot be multiplied by other quantities, other units. Okay, so degree cannot be multiplied by other units like the inches, meters. They are not compatible. Okay, problem 4. Problem 4, we have a angle. Theta is between 0 and pi over 2. And we know sine theta is square root of 3 over 4. We're looking for secant theta. Okay, now this one is simple because this is acute angle. For the acute angle, you can just realize it in the triangle, right triangle. You assume this is a theta. Sine is opposite of hypotenuse, so this opposite is square root of 3. Hypotenuse is 4. Then you can compute the adjacent. Adjacent A. So A squared, by the Pythagorean theorem, A squared plus square root of 3 squared is equal to 4 squared. So A squared plus 3 is 16. A squared is 13, so A is a square root of 13. A is square root of 13. Then secant theta. Secant theta is hypotenuse over adjacent. Is hypotenuse over adjacent. If you don't remember what is the definition of secant, but at least you should know that secant is 1 over cosine. Secant of theta is 1 over cosine. Cosine is adjacent over hypotenuse. So 1 over this square root of 13 over 4 means you're going to flip it. So again, you get 4 over square root of 13. So secant theta is 4 over square root of 13. Right? Problem 5. Find the exact value of the expression. So 1 minus cosine pi over 6 squared minus cosine pi over 3 squared. Well, there are multiple ways to do it. If you can remember or memorize it, you can directly memorize. So cosine pi over 6. What is a cosine pi over 6? It's a square root of 3 over 2. And cosine pi over 3 is 1/2. If you remember it, they are like this. Then when you square them, so square root of 3 over 2 squared is 3 over 4. 1/2 squared is 1 over 4. Minus 3 over 4 minus 1 over 4 means minus 1. 1 minus 1 is 0. So it's not too bad. If you don't remember this evaluation, you can recall the other one. So cosine of x is equal to sine pi over 2 minus x. Cosine of x is equal to sine pi over 2 minus x. So cosine pi over 3 is equal to sine pi over 2 minus pi over 3. Pi over 2 minus pi over 3 is a pi over 6. So you get a cosine pi over 3 is equal to sine pi over 6. And then you can apply, you see, cosine pi over 3 is sine pi over 6. So you have sine pi over 6 squared. If you factor out the negative sign, you have cosine pi over 6 squared and sine pi over 6 squared. And this comes from the basic trig identity. Cosine squared plus sine squared is equal to 1. So 1 minus 1 is 0. You can also evaluate this expression by this method. Right? And second one, 1 plus tangent 30 degrees minus cosecant 45 degrees. Okay, so you have to remember that tangent 30 degrees is square root of 3 over 3. Cosecant 45 degrees is square root of 2. Cosecant is sine, 1 over sine. It's a 1 over sine 45. It's a 1 over square root of 2 over 2. So it's a 2 over square root of 2. 2 over square root of 2 is a square root of 2. Whatever. You just memorize it. Okay, so you get 1 plus, this one is 1 over 3. Square root of 3 over 3 squared is a 3 over 9. 3 over 9 is 1 over 3. Minus 2. Square root of 2 squared is 2. So it's negative 2/3. Negative 2/3. All right. So problem 6. Find the exact value of each of the remaining 5 trigonometric functions of theta. Cosine theta is 3 over 5. Theta in quadrant 4. Quadrant 4. All right, so when you have something like this, you first ignore this quadrant 1, 2, 3, 4. You just assume it is in quadrant 1 and find the corresponding sine, cosine, tangent, cotangent, secant, cosecant. How do you find it? Cosine theta is a 3 over 5. Remember, you put this theta in the triangle, right triangle, and by the Pythagorean theorem, 3, 4, 5 always form a right triangle. Side 3, 4, 5 always form right triangle. And then from here you will see that sine theta is, be careful, it's not the final answer, I just give you the idea. Sine opposite over adjacent, hypotenuse, opposite of hypotenuse. Cosine is already given, 3 over 5. And the tangent theta, opposite over adjacent. And cotangent theta, adjacent over opposite. And secant theta, hypotenuse over adjacent. Cosecant theta, hypotenuse over opposite. Okay, so not done. We're not done. And then remember, this only comes from this right triangle, but combined with the condition theta in the quadrant 4. In quadrant 4, only cosine and the secant are positive. In quadrant 4, only cosine and secant are positive. Other 4 trig functions are all negatives. You put a negative sign. Okay, you put a negative sign for other 4 values. And that's it. That's it. So you first assume it's in quadrant 1 and get the values. And then based on this quadrant, you add the negative sign. And except quadrant 1, you always have 4 negative signs. Quadrant 2, the sine and the cosecant are positive, other 4 are negative. Quadrant 3, tangent and the cotangent are positive, other 4 are negative. Quadrant 4, cosine and the secant are positive, the other 4 are negative. Except quadrant 1, there are always 4 negative values. Right? Okay. Next, problem 7. Y is equal to negative 1/2 cosine of 3 over 2 x and plus 2 over 3. We're looking for the amplitude. The amplitude is always the absolute value of the sine, cosine, trigonometric functions, coefficient. So its absolute value of negative 1/2 is 1/2. And the period of the the period is always 2 pi over 3 over 2. 2 pi over the coefficient of x. So it's a 4 pi over 3. 4 pi over 3. Okay. All right. So that's it. So 1/2 and 4 pi over 3. Problem 8, we are going to evaluate each expressions. Tangent negative pi. So here we use the relations between the 6 trigonometric functions together with the period. Remember, tangent, cotangent, they have period pi. This works for tangent. This also works for cotangent. And the other 4 trig functions, they have period 2 pi. Okay, so sine, cosine, secant, cosecant, they have period 2 pi. Okay, so here, for example, you get tangent negative pi. Tangent negative pi, if you add pi, it is equal to tangent 0. Tangent 0 is 0. Tangent 0 is 0. Cosecant negative pi over 3. Cosecant negative pi over 3. And remember here, the cosine negative x is cosine x. It's an even function. So it directly gives us secant negative x is secant of x because it's a reciprocal of it. Okay? In 6 trigonometric functions, only these 2 are even function. Others are odd functions. Other 4 are odd functions. Cosecant is one of a sine. It is also odd functions. You move this negative sign forward. You directly move it forward. All right? Cosecant pi over 3. And the cosecant x is 1 over sine. The reason I write the cosecant x as this because I normally just recall or memorize the value of sine, cosine, tangent. I don't memorize the value directly. Cosecant pi over x, pi over 3. So sine pi over 3 is square root of 3 over 2. So it's a negative 1 over square root of 3 over 2. It's negative 2 over square root of 3. In the exam, you can leave it like this. You don't have to rationalize it. Okay? You can just leave it like this. Negative 2 over square root of 3. And secant, negative 60 degrees. Okay, remember secant is an even function. It is equal to secant of 60 degrees. Secant of 60 degrees, secant of x is a 1 over cosine of x. Cosine 60 is 1/2. Cosine 60 degrees is 1/2. Cosine 60 is equal to 1/2. So 1 over 1/2 is 2. So secant negative 60 is equal to 2. All right? And sine negative 135 degrees. Sine negative 135 degrees. So first, sine is an odd function. You move negative sign forward. And 145, do you know what it is? 145 is this diagonal. Diagonal, so it is negative square root of 2 over 2. Square root of 2 over 2. In the second quadrant, the sign is positive. So without the negative sign, it's a square root of 2 over 2. With this negative sign, it's negative square root of 2 over 2. All right? Okay, so for this one, if you don't remember the value of sine 135, you can also use the reference angle. If this angle is 135 degrees, then the corresponding reference angle is 45 degrees. Okay, so you be careful, I do not finish it. So angle, sine of this angle is a sine of reference angle with plus or minus sign. 135 is in the second quadrant. Sine is positive. So if you add sine, it's still the positive sign. So sine 45 is square root of 2 over 2. So that's why sine 135 is also square root of 2 over 2. Right? So here is a plus sign. When you get an angle, you find the corresponding reference angle. You replace the original angle by the reference angle, but that's not the end. You have to adjust the plus or minus sign. In the second quadrant, the sign is positive, so it seems you don't put the positive sign. Then sine 135 is equal to sine 45. All right? It's problem 8. Problem 9, you just follow the suggestion, follow the formula to do the evaluation. So projectile motion, the path of the projectile fired at an inclination theta to the horizontal with the initial speed. So basically, you have the rock. This is a horizontal line, and you're going to have the inclination, and the angle is a theta. You project it with the angle, and the initial velocity, initial speed is v0. And then when you throw it, you will get a parabola. It looks like this, the projectile. All right, so it's like when you throw a chalk, you will see something like this. And in this part, there is a height h, and there is also the range. Range means this r. Okay, So the height and the range, of course, depend on this speed. If you throw it hardly, then the range will be bigger. If you throw it very soft, then the range is going to be small. And also you will see that if you make this angle a little bit bigger, then the range will be bigger, right? The range and the height both depend on this initial speed and the inclination angle. So in the problem, the formula is given.